Hi, my name is Sam, and today I'm going to be talking about natural gas, advantages and disadvantages. First, I'm going to start at the disadvantages, then I'm going to go over to the advantages. So, first on the disadvantages is flammable and toxic. Leaks can be extremely dangerous. The main risk comes from the fact that it is naturally odorless and is difficult to detect. Environment impact. When it burns, it contributes to the greenhouse effect. Processing. In order to use it as a fuel, it must be processed, which results in several byproducts. It's non-renewable. It is a finite source of energy. Efficiency in transport. When used to fuel cars, the mileage is lower than gasoline. So I'm going to talk about some fast facts right now. So LNG is a liquid gas, which is really, really cold. And grounding in the mechanism on gas meters that are right outside of your houses, make sure that it does not get lightning damage and explode. Smoke alarms are useless for this. Smoke alarms cannot detect natural gas. That's why you need a carbon monoxide alarm. It is pretty expensive. It is more expensive than oil or coal. And natural gas comes into houses with metal pipes or copper pipes, and they heat up your house. NG is hotter than LNG. LNG is liquid natural gas. NG is just natural gas, which is really, really hot, and LNG is very, very cold. It causes global warming, so many polar bears will die each year from this. They will drown. And Denmark has very, very long pipe networks that cross over miles, and 5.29 trillion metric tons are used every single year on natural gas. It's found in mines or just like underground. And now I'm going to talk about the advantages of natural gas. So advantages of natural gas is it is cheaper compared to other fossil fuels and electricity when used for supplying home appliances. Environment, it is not polite to ground or water. Transportation, delivery can be made via sea and land. Multi-use. Natural gas is a multi-use fuel. Availability. It is abundant and available almost worldwide, almost everywhere. And it is a high-quality instant energy, which means it is very good to use, but it is not good to breathe. And natural gas is better for the environment than coal or oil. It's one of the world's major fossil fuels, and it is used in houses to heat up the house or turn on your fire or stove. And it is cleaner than coal, because coal will be messy and it puts black powder everywhere. And it helps with furnaces, and yeah, I already said this, it helps to keep you warm. It's way better than coal, way better. Use it instead of coal. And carbon monoxide alarms save people. So if you have a carbon monoxide alarm, you could it'll save people if there's any like leakage, like the stove is left on just a little bit and the fire isn't on, then it could kill people if you don't have a monoxide alarm to start beeping. And now I'm gonna show you the pictures. So this is what the natural stove looks like. It's like fire, and if the fire doesn't go on and you turn it on, then you have to turn it back off so that not much natural gas comes out. This is what the natural gas meters look like. So it's close. This is a close view, and this one is the far view. So it's not as close as that one. This is what it should look like, and there is no mechanism that stops the lightning damage. The lightning damage mechanism, it's metal wire that goes into the ground, so the lightning finds the quickest way to the ground instead of exploding the natural gas. This is the pipelines. This is a very, very confusing pipelines, I know. And then this is how the natural gas is measured. And this is some pipes that are going quite far and they're making some turns. The middle one is going further than all of them, I'm pretty sure. And then LNG is a highly concentrated energy. It's super, super concentrated. And then if you heat it up, it'll turn back into gas. So in 2,918 years ago, natural gas was used with lots and lots of people. And seismic exploration is like ultrasound. It's how they see what's underneath of the ground. So if you just go outside and do it, then you can see what's underground. You can see if there's diamonds or something. And then that's all of my poster. And right up here is the website that I use to get all of these. And these are just pictures I found online by searching up natural gas pipes, natural gas meters outside of a house, and just natural gas. And that's it. Thanks for listening.
Wonderful presentation.
Thanks.
Are you taking questions?
No.
No questions?
No questions.
Well, you did cover quite a lot of that.
Yeah, I know.
I was just wondering how does the gas actually enter the house?
It enters the house by pipes coming from long distance, just like in Denmark. The pipes can be miles and miles long, and that's how they enter the houses. They transition into some little houses that separate take each little bit of gas and put it into some little pipes, I'm pretty sure, so that they can go to like our house or anyone else's house.
So the pipes that go to people's houses are smaller than the big pipes when they start.
Yeah, they're like the toilet paper rolls, the little cardboard thing. I think they're like either a little bit smaller than that or a little bit bigger, maybe even the same size, but they're not as big as the huge ones like right here.
Yes.
They're much tinier. They're a lot smaller than
Similar to the picture on the left.
Yeah, this is what they would look like.
And they're underground.
Yeah.
What's the difference between liquid natural gas and natural gas?
Natural gas is a gas that'll float up, and it is very, very hot. And it also smells like rotten eggs to tell you that there is natural gas in your house and it could explode. And then liquid natural gas, I think it still smells like rotten eggs, but it's just a liquid that is still flammable. And it is very, very cold, so if you put your hand in it, it'll freeze instantly. It is like, I'm pretty sure it's, it can be like it's negative 259 Fahrenheit, I think.
Wow. How do they make liquid natural gas?
They freeze it, I'm pretty sure. They should, I'm pretty sure that they put the gas into a chamber, make it cold, so that it'll form back into a liquid. So it was naturally a liquid before that they turned it into a gas. Before it's a gas, it's a liquid. That's how they find it. It's a liquid.
Okay. Interesting. Well, thank you very much, Sam, for your presentation. Very well
You're
done.
welcome. And thanks for listening.